Hello everybody. In this video we're going to be looking at how you can use conversion factors and the factor label method to make conversions. You might recall from the first video that a conversion factor is just a ratio or a fraction made of two measurements which are equal to each other but expressed in different units. These numbers, when written as a fraction, are always equal to 1. Now let's look at how we can use those conversion factors to solve a problem. Suppose we need to know something like this. How many months are in 6,722 years? We start by setting up a fraction and we put it in parentheses. The value that we know, in this case 6,722 years, goes on top of the fraction in the numerator, and then we put that over 1 in the denominator. Remember, the 1 doesn't really change anything. Just dividing by 1 means it's still the same value, but it helps us remember what's a numerator and what's a denominator. Then we put in another set of parentheses for the conversion factor. The conversion factor needs to relate time as measured in years and months. Now, we know that 1 year and 12 months are the same amount of time. So we have two possible ways that we could write this conversion factor. The first is like this, with 1 year on top and 12 months on the bottom, or we could write it like this, with 12 months on the top and 1 year on the bottom. In both of these cases, since 1 year and 12 months are the same amount of time, they're both equal to 1. And if you multiply 6,722 years by 1, you're not going to change anything except the units. But which one do we choose? Well, let's show you how to do it using both of them. First, let's take this one on the left up and use that as the conversion factor. If this were our conversion factor, we multiply by everything in the numerators and divide by everything in the denominators. So we would take 6,722 years times 1 year divided by 1 divided by 12 months, and since nothing cancels out, we would get an answer of 560 years squared per month. So we've got an answer, but that unit, remember the units are critical here, that unit on the answer of years squared per month is kind of nonsense. That doesn't mean anything. So that tells us that form of the conversion factor is not what we want. So let's show it with this other one. If we write it this way, now notice that the unit years is on the top in the first set of parentheses, but it's on the bottom in the second set of parentheses. That means the unit years will be canceling out. Now when we multiply all of our numerators and divide by all of our denominators, we get 6,722 years times 12 months divided by 1 divided by 1 year, and again the units years cancel out, and so we just get 80,644 months. And the unit now tells us that we are correct because it's the unit that we need for our answer. So the units can help us to guide our thinking. So what if we want to do this with a metric system? The metric system is used a lot, and it uses prefixes to indicate the size of things. For example, in the metric system, it uses prefixes like micro, which mean 1/1,000,000th, milli is 1/1000th, centi is 1/100th, or for big values, it uses prefixes like kilo and mega and giga. And we often get confused, or students often get confused, well, do I need to multiply by 1,000 or do I need to divide by 1,000 to make this conversion? Well, let's show how we can use the factor label method and the units to guide us through the process so that that will always be taken care of. First, one conversion factor that's really handy to remember is that 1 meter of distance is the same amount of distance as 100 centimeters. Then, if we have a piece of data like 1.30 centimeters and we need it measured in meters, we can use that conversion factor to help us solve it and convert it. Our process is the same as in the last problem. We start with a parentheses divided into a numerator and a denominator. We take the piece of information that we know, in this case the 1.30 centimeters, and we put that on the top and we put it over 1. Then we set up another set of parentheses for a conversion factor. Now again, if we know 1 meter equals 100 centimeters, we can write our conversion factor two ways. 1 meter over 100 centimeters, or 100 centimeters over 1 meter. The one we choose, we let the units guide us. we look up here at our known quantity, and this unit right here, centimeters, is on the top. That's what we need to cancel. So we want to choose the conversion factor that has centimeters on the bottom. That's this one. So that conversion factor goes up here. Notice the unit centimeters now cancels out, and it shows us that if we simply take 1.30 divided by 100, the unit centimeters will cancel out, and our answer will be measured in meters. 1.30 centimeters is the same thing as 0.013 meters. So, what if we have a long conversion, one that involves multiple steps? Does it still work? Well, let's take a look at a question like this. Suppose for some reason we needed to know, well, who was the president a billion seconds ago? Well, a billion is such a huge number, I can't really visualize how much time that is. I need to convert it into something that's easier to think in, like years. But I don't know a conversion factor that relates seconds to years. We can still make the conversion. We just have to start with what we know, just like we have before. So we start with our parentheses, divide it into a numerator and a denominator, and write the information that we know. And the thing that we know is 1 billion seconds. Now, a billion seconds is a big number to write out, so I put it in scientific notation. So 1 times 10 to the 9th seconds, that's just scientific notation for 1 billion seconds. Now, since I don't have a conversion factor to go from seconds to years, I think, well, can I convert seconds into anything? And one that I know is that, well, yeah, since seconds is what I need to cancel out, I need seconds on the bottom, and I need to convert into something else, and I know that 60 seconds is 1 minute. So if I set up my conversion factor this way, the unit seconds cancels out, and if I divide a billion by 60, I would then know that a billion seconds is the same thing as 16,666,000 minutes. But I can't really visualize that either. That's a big number as well. So let's do another step. Let's convert this minutes into something else. Well, another factor that I know, I need to cancel out this minutes because it's on the top, and I want minutes on the bottom then. So I know that 60 minutes is the same thing as 1 hour. So notice again, my unit minutes cancels, and if I now take and multiply by everything on the top, a billion times 1, divide by everything on the bottom, divide by 1, divide by 60, divide by 60, I would find out that that billion seconds is the same thing as 277,777 hours. Again, too big to think in. I need to convert this again. So once again, hours is the unit that I've got to convert. I know that 24 hours is the same thing as a day. So let's set it up. Cancel that unit hours out. And if I do this, multiply by all the numerators, a billion times 1 times 1 times 1, divide by 60, divide by 60, divide by 24. I then know that that billion seconds is 11,574 days. Still having a hard time picturing that. One more step. Let's convert from days into years. So we put in one more conversion factor. Again, days is the unit here that I need to cancel out, so days has to be on the bottom, and my last conversion factor. And I know that 365 days is the same thing as 1 year. Once again, the unit days is now canceled out. I multiply by all the numerators, divide by all the denominators, and so 1 billion divided by 60, divided by 60, divided by 24, divided by 365, finally gives me this answer of 31.7 years. And that's a value which I can finally kind of visualize. I know about how long 31.7 years is. And since it's 2021 when I'm making this video, 30 years ago would have been 1990.7, a little bit more. So at the end of 1989, let's see, it was right then, I think Reagan transferred to Bush. So about 31 years ago, George H.W. Bush was the President of the United States. So, if we want to solve problems involving conversions, this is how we can do it. The key things are always start with what you know, set up your conversion factors so that the units cancel out, and then multiply by all the numbers on the top, divide by all the numbers on the bottom, make sure your units work. That's it for now. Learn lots.